Hello, everyone. Welcome to the session on Future of Search at Snowflake. I'm Yogita, Product Manager for Search at Snowflake. I'll be co-presenting with Vinayak, who's the co-founder and CEO of Mark5. So the agenda today is we'll talk about how search features evolved in Snowflake. And then Vinayak will talk about Mark5 and how it could help to move your search workloads from other platforms to Snowflake easily. So before we start, a quick show of hands, like how many of you here know search optimization as a feature in Snowflake? Are aware of it? Okay, that's good. And how many of you are like Elasticsearch customers or like use Elasticsearch in some way? Okay, so you'll all find this talk very interesting, hopefully. So before we get into all of the search features, we thought to pick out a few selective queries that are common in any data platform. So I have 4 of them here. The first one is point lookup queries. These are queries where you're trying to find a few records that match your criteria amongst all your data. The second is top K queries. These are cases where you're finding the K highest or lowest ranked results from all your data. A frequently used query type is joins. This is a popular one is star joins, where you're joining several small tables with one large table. And the last one is the more involved full text search, where you're searching for tokens amongst all your data. The great underpinning of all of these queries and everything else in Snowflake is the pruning capability. So let's talk a little bit about how pruning works. In Snowflake, tables are divided into small, compressed, and immutable contiguous storage called micropartitions. While we are ingesting data, for each of the values in the column, we collect statistics such as what is the number of distinct values, what is the minimum seen, what is the maximum seen, etc. These statistics are stored in a special file in Snowflake. And pruning is the process where we use these statistics whenever a query comes in to eliminate reading several of these micropartitions, thus reducing the amount of data that is read and also decreasing the query runtime. But there are cases in which pruning can do even better. For example, let's say the data that you're ingesting or the columns that you frequently query, it's not naturally ordered, or you're not using clustering to order that data in that column. In such cases, there could be slow-running point lookup queries. By point lookup queries, to clarify, I mean queries where, like the needle in haystack queries, where you're finding a few rows amongst all your data. To help with this problem, we came up with search optimization. What we essentially do here is, along with the statistics that are already collected, we build a data structure that contains more information about the values itself seen in the data, which are used to further prune out micropartitions. So let's look at how search optimization works in a little bit more detail. So like I was saying, we built a special data structure. Essentially, you can think of an index, which tells that for a given value, which are all the micropartitions that don't contain that value. So for example, there is a query here where you're trying to find all transactions made by Martin. So search optimization builds an structure or data structure which contains this information for Martin. And using this extra information built by search optimization, you're able to eliminate more micropartitions and essentially just scanning one micropartition here in this use case. So this helps to reduce the runtime of your queries for several point lookup queries. So let's also look at a couple of use cases where search optimization really shines to put this into picture. For example, we have a Fortune 500 financial company who has petabytes of data. And here are a couple of things that they wanted to do with their data. The first use case is amongst all their trade data, they wanted to find a few trade information or trade data that match a certain criteria during dispute management. The second is amongst all their customer data, they wanted to find information for one particular customer for GDPR purposes. The common thing amongst both these queries is that they're point lookup queries, and they needed these to run faster. So search optimization became a natural solution. So when we introduced search optimization for the first time in GA in 2021, we heard a lot of great things from customers. For example, here, a cybersecurity customer said that with search optimization, they're able to quickly grow through a large volume of data because of having search optimization. The second thing is, here is a financial customer who said that their they saw queries speed up of 143x when they're looking for both accounts and transaction data. But we didn't stop here. So early this year, actually in April, we did a major update to search optimization, almost like a 2.0. We extended the capabilities to support more data structures or data types and also more searches. So we support substring searches, support semi-structured data and geo searches now. Let's look into a little more detail for each of these type of new things that we do. Faster substring searches. For example, substring searches are one of the most common use case that customers have and that they do in Snowflake. For example, observability team in a large design company wanted to find all requests that match a family of URLs. They wanted to do this to set up alerts and monitoring. This is how their query would look like in Snowflake. The request URI is the column, and this is the template or the substring that they want to match on. All of these thank you cards, congratulation cards, etc. would match for this query. So these kind of queries are now faster in Snowflake with the support for substring searches. Let's look at how this is made possible. What we do essentially is for each of those strings, we create or we index all of the substrings that are more than 5 characters long. So when you do substring searches with like, I like, contains, are like, etc., you'll see that these searches are much faster with search optimization. To add or enable a column for search optimization using the substring method, this is how you will do it. You'll say alter table T, add search optimization on. Substring is the method followed by the column that you want to enable for search optimization. So a query that looks like here where request URI, I like or like, and then the pattern will use search optimization. Now let's look at the second feature, which is faster searches in semi-structured data. In Snowflake, when we're saying semi-structured data, we are essentially talking about 3 things. One is variants, the second is objects, and the other one is arrays. It's very common for customers to get their data, which are of JSON type, etc., into one of these 3 types in Snowflake. So a security team, for example, a security team in a financial company has this use case where they wanted to find amongst all their log data any indicators of an attacks that could be possible from a set of IP addresses. They needed this for threat investigation purposes. And this is how their queries would look like in Snowflake. So if this IP address was stored in a variant, it would look like the first over there. Whereas if it is stored in array, it would most probably look like the second. So these kind of searches are much faster with search optimization support for semi-structured data. So how do we make this happen? What we do is we index all the leaf nodes in the variant as part of this data structure I was talking about earlier. While we are indexing, we also detect the type of this data that we're indexing. So any of your searches which contain the predicates like path to field, and then like, for example, here given here, which casts a variant into a certain type and matches it, or use array contains, array overlap, etc., will be faster with search optimization. To enable a variant column for search optimization, this is how the syntax looks like. It's very similar to what we saw in the substring case, but the only difference is here we're doing an equality matching, and the column there can either be the full variant column or a subpath in the variant that you're interested to enable for search optimization. This decision you'll be making based on what kind of queries you want to accelerate. So a query which looks like the below one here will be faster with search optimization once you enable it. So here is a testimonial from a customer or a Panther who's a cybersecurity partner once they enabled this feature, they saw that their searches in variant data were approximately 100 times faster with this feature. So this is a significant number. So any security analyst, for example, looking through their data and do not have to wait for minutes, but will probably will get the results back in seconds. And you can imagine why this would be important, because during a threat investigation, time is of essence. So the next feature is faster searches in geodata. Any application that is using any form of maps where, we require these kind of searches where you're zooming into a certain part of the map to be really fast and interactive. For example, an investment management company wanted to evaluate the attractiveness of an investment in a certain area. What they needed was really fast geo-based searches. Their search in Snowflake looked like this. They used the st_intersects function, and they were specifying a bounding box, which is essentially the area that they want to look for. And also the last one is the column which contains their geographical data. So these kind of searches are much faster in Snowflake now with the search optimization functions. So again, how do we do this? We do this by indexing all of these bounding boxes as part of the index. So any of your queries that uses predicates such as st_intersects, contains, etc., could be much faster with search optimization. And very similar to what we saw for substring and variant, the new functions, the syntax is similar, but the new keyword is geo, and it's followed by the column that you want to enable for this function. So this graph here shows the results we saw a location identifier company saw once they enabled this feature for their geographical searches. The yellow dots here signifies is a query run without search optimization, whereas the blue ones is the same query run with search optimization. As you can see from this graph, that some queries which were taking nearly 30 to 40 seconds just take about a couple of seconds with search optimization enabled. So this customer they had an interactive map, and they saw that these searches get much more usable with this feature. So we've talked about all the performance gains that comes from using search optimization. So let's talk about the different costs that are involved when we talk about search optimization. So two costs. The first one is the cost for building the index or the data structure that we were talking about. This is the initial cost. And the second one is the maintenance cost. So as new data comes into that column, or you're deleting data, we need to make sure that this index is up to date. This maintenance task is a background job that runs, which is optimized such that it runs more efficiently based on your workload. So using that cost estimation function, you get both of these values. Based on all the DML, you also get what is your estimated maintenance cost. So for all the costs that you pay, what are the benefits that you see? One is that your point lookup queries could be significantly faster. And there are cases where customers are trying to downsize their warehouses because now their point lookup queries are much faster. So that's the benefit side of things. But we are always thinking about how to make this feature more optimal or cost effective for you. And there are a couple of things that we've done. The first thing is we've given some of the control back to you. For example, earlier, search optimization could be enabled on the whole table only. So the whole of the table needed to be indexed. But now we have a new feature which allows you to choose which columns you want to index. So based on your workload, you could choose which columns you want to index now. So Deliveroo, a company who uses search optimization a lot, adopted this column selection feature, and they saw that their search optimization cost nearly came down by 90%. The second thing is we are always trying to make these maintenance tasks more and more efficient. So just in the last 1 year, we've done 6 efficiency improvements. As the graph here shows, the cost per TB for indexing your data has drastically come down since last year. Just in the last quarter, we did 3 such improvements. And on average, customers saw that their search optimization costs reduced by 31%. And we'll continue making these efficiencies for making your maintenance costs much cheaper. So we talked a lot about search optimization. What is the benefits of having search optimization and also the costs involved? But since this conversation is just about general search, we also did a lot of things to improve general pruning. And I'll be talking about one such feature here. A common use case across industries is to look at top K items, where you want to find the K largest or the least based on some condition. For example, a cybersecurity company wanted to find the most recent 100 logs with the message access privilege updated. So essentially, in Snowflake, that would mean a query which has both a limit and order by. We have a new improvement where we smartly determine when to stop scanning, and we do not need to order all your data and then pick the top 5 items. So with this new improvement, we're seeing that your long-running queries or top K queries are almost faster by 38%. And when we, again, look at it on a holistic basis for a few customers over a short range of time, this is how it looked. So the red dots here shows the query runtime without the top K pruning feature, whereas the yellow dots here signify is the same query run with the top K feature. We saw some massive improvements for some queries. Some queries that took about 7 to 9 minutes are taking only 15 to 50 seconds with this feature. We always say nothing comes for free, but this actually comes for free. There is nothing that you need to do, nothing to enable it. It makes, if your query is eligible, it's going to be faster. So we've talked a lot about what we have done in the last 1 year, but now what are we thinking? A little glimpse into what we are thinking into the future. So the one thing is we've realized that top K queries are really important for several industries, and we're making more and more investment in this space. So you'll hear more about how we are improving this query type. The second is joins. One common join type is the star joins, and we're going to release a feature in search optimization that to help make joins faster. And the last, also very exciting space is the full text search. And the first step here we're taking here is the integration with MarkFi, which will help moving your applications that are running in other search platforms like Elasticsearch to Snowflake more easy. To talk a little bit more about this, so let's say you already have an Elasticsearch application that you're running. A common pain point that we have heard is that it's too costly. It takes a lot of effort to maintain this. A lot of management is needed for this. But you have all of your other data in Snowflake, so you do not really have to perform the searches outside of Snowflake. You do not need these data silos anymore. MarkFi has built an amazing application by which you can move all of your, do a very similar search in Snowflake without changing any of your application code. And I'll hand it over to Vinayak from here to talk more about this.
Thank you, Yogita. So wanted to quickly talk about Mark V a little bit. So Mark V on Snowflake is essentially, if you've been using Elasticsearch or OpenSearch, it's an API-compatible middleware that runs on top of Snowflake, and from a consumption standpoint, looks and feels like Elasticsearch, but under the covers uses the capabilities of Snowflake, specifically the search optimization and the semi-structured data and the declustered compute and storage and all of the benefits that one gets from Snowflake in order to achieve the same outcome. What I have seen with multiple people who use Elasticsearch usually is that they tend to place a lot of their data in Elasticsearch. They start with Elasticsearch because it's very easy to use. It doesn't care about the schema. You can throw semi-structured data at it. Very powerful query language. You can start querying it. But very soon people realize that it starts bursting at the seams. And so now they start looking for a place to keep their long-term data because not all of it fits in Elastic. And the next step is now you have two systems, right? So your long-term data resides somewhere and your 30 days or 60 days is in Elastic. But now you have two systems that you have to query against, two different query languages, two different ways of managing this data, and then you replicate the data, something is going to go out of sync. So this is really where we came from when we said, let's build Mark V. The idea is you're putting your data into Snowflake to begin with because it can handle both the small as well as the large. right? But at the same time, from a usage standpoint, if you're familiar with Elasticsearch or OpenSearch, wouldn't it be great to be able to use the same capabilities that you already have, dashboards that you've pre-created on this platform, and be able to use that without having to change any of your code? So what we do, as I mentioned, is we look like OpenSearch or Elasticsearch from the top, but as you ingest data through the bulk API that Elastic offers, which is the same API we offer, by the way, we stream that into Snowflake using the Snowpipe streaming protocol. And then whenever queries come in, we basically push queries down to Snowflake in the form of SQL. So in terms of functionality that Mark V offers on top of Snowflake, is it kind of complements what Snowflake does with additional functionality that one is used to in something like Elasticsearch, right? So for example, Elastic is really good about providing APIs for tokenization of the data on the way in. In fact, that complements the search. So you can start looking for things so that your search is enhanced by means of tokenization. And Elasticsearch or OpenSearch contains about 75 built-in text analyzers, and it has APIs for building your own text analyzers. So Mark V supports all of that. In terms of full text query types, we support around 50 different full text query types. In fact, in the demo, I'll show you a few that one would, again, this complements what Snowflake provides, but at the same time leverages the capabilities of what Snowflake is really good at. And finally, Elasticsearch supports a whole bunch of data types where people have gotten used to, for example, IP addresses and CIDR lookups, arbitrary, not just octet boundaries, but anywhere within the CIDR and so on. So I'll show you some of those in the demo also. To recap, here is kind of the data flow of what happens when one deploys Snowflake, Mark V on top of Snowflake. So on the left-hand side, what I have there is a sample log in JSON format. And if one were to ingest that data into Mark V using, let's say, the OpenSearch or Elasticsearch bulk ingestion API, we would stream that into Snowflake using Snowpipe streaming, and we turn the fields in the log entries to start to use the semi-structured capabilities of Snowflake. For example, the destination here, which is a nested object, would turn into a variant, and user agent tokens through tokenization would turn into an array, and so on and so forth. And similarly, when a query comes in, which says, for example, anything that begins with Moz, we turn that into SQL against these columns and use the search optimization capabilities. But from a usage standpoint, the user doesn't have to worry about search optimization. They don't have to worry about configuring things. Mark V does that automatically for you, and we support all the capabilities that Elastic offers. So with that, let me quickly jump into a demo. So here I have, what you're seeing here is essentially what we call Mark V Search, which is a rebranding of Kibana or OpenSearch dashboards on top of Mark V. So from a UI standpoint, it's essentially showing the same DSL queries that one issues against Elastic, which in turn Mark V turns into SQL against Snowflake. So in here, we have a few samples preloaded with data that in Snowflake. I'm just going to very quickly show you some functionality that we offer. I don't know if the text is too small, but this is a Yogita in the first part of her talk. She talked about a financial services company which uses the specifics of that is it's a brokerage house that uses fixed message format for capturing transactions of stocks. And the specific use case here is the CSM or the customer service managers use Lucene queries today with Elasticsearch to identify potential, like people call in, the customer calls in saying there's a discrepancy they observe in a trade, and so they use Lucene queries to search against the fixed data. So for example, let's see. So I'm going to add a filter, say, let's see. So here, this is a straight up token filter. So where we are saying some column in the fixed data is equal to some value. And doing that search, under the covers, what's happening is it's issuing the Elasticsearch DSL, and it uses search optimization under the covers and basically produces the records that you're seeing here. And as a user, now this particular search I did was identifying the customer who called in, and now I can see when the timeframes when they issued trade requests, and then I can jump into any specific time boundary to zoom in to a specific fix record to identify any of the data that the customer owns. And so this is how the customer service representative uses Kibana today to handle this workload. And with Mark 5, it's seamless because they don't need to retrain. It's exactly the same process. It's just running on top of Snowflake. This was one use case. I want to show you another. This is an e-commerce type demo where we have a few items being bought and sold. And what I'm going to show you is a search here. Let's see. So I'm looking for the phrase light blue. And when I do the search, it comes back with 33 hits. But remember, this is a phrase search, right? This is not a classic token lookup or a point lookup. It is looking for both those words in that specific order. Now, one of the things that you can do with a full text search engine is do proximity search. So for example, I can say light blue within 2 keywords or within 2 tokens of each other. And when I do that, you'll see that this jumped from 33 to 37 because now it started allowing for other possible things to be introduced between light and blue, right? So again, notice how interactive it is and seamless. Again, under the covers, what Mark 5 does in order to solve this problem is we build derived columns which help run queries like this, right? So this is not something you would be able to do with SQL, with Snowflake, but what Mark 5 does is build some derived columns which help with proximity search. And the last query I'll show you today is related to CIDR lookups. So I'm going to do 10.12.0.0 / so let's say I think it is ID dot. .0.0/8. So this is a CIDR lookup that's being performed against the data, looking for specifically something within the /8. I don't know if I'm able to read it or not. Give me one moment. Let me mirror the display so I can see what I'm running. So this is basically a query that's running against the data set that is doing a CIDR filter on in this case, just the first octet, right? But under the covers, again, we build an index on IP addresses so that we can do CIDR lookups Again, this is not something that is natively supported by Snowflake. It is something that Mark 5 builds in addition to the fields, right? Again, I have more demos I can show, but I mean, because of time, I'm going to stop here. If you want to know more about Mark 5, come see me later, and happy to show you more use case driven demos about Mark 5. With that, I want to switch back.
Essentially done with it, just had a summary. So if you wanted to learn more about fast point lookups, other pruning capabilities, like come talk to me. In the future, we're looking at making search optimization and some of these pruning capabilities much, much better. And if you have any specific questions about moving your Elastic workloads to Snowflake, definitely talk to Vinayak. We can see how Mark 5 can help bring your full text search applications into Snowflake more easily. That is all. Thank you.